ladies and gentlemen, you're most welcome to this YouTube channel. So at the moment, we are going to look at how to solve simultaneous equations, and we're going to use this as our example to demonstrate how to use these three methods. So let us be very attentive and we understand these methods. So first of all, we are going to use the elimination method. And under the elimination method, you will make sure that, let us first write our first equation here, 2x plus y is equal to 5. And the second one, we shall make sure that x is under x. So I shall write 3x first, such that x is under x. And now 4y next is equal to 10. And I should make sure that coefficients of a certain variable I'm going to eliminate are equal. For example, this is 2, this is 3. This will signal to me, if this is 2, this is 3. So I'm going to use this 3 to multiply it on the whole of that equation, and this 2 to multiply it on the whole of this equation. So this equation becomes 3 times this one, 6x. This one becomes 3y equal to, this one becomes 15. Still the same thing. This becomes 6x plus 8y equal to 20. And after that, I will now subtract. I'm getting this equation minus this equation. The whole of this equation minus this one. And so I can just use here a line. It's better, just use a line. So 6x minus 6x will give me a 0, and that is the major point of elimination method. So I'm eliminating the x terms, and at the end I will be left with 3y minus 8y, a small quantity minus a big one, gives us a negative. So this is a negative 5y equal to 15 minus 20 gives us a negative 5. Don't divide from this very step. Never divide from this very step. Instead, rewrite again that step, and now divide it by the coefficient of y. Of course, divide by negative 5, also by negative 5 this negative 5 this side. So your y will remain as a 1. And after getting your y as a 1, we will come back to one of these original equations, and now you write there your y as 1. Instead of writing y, I will write 1 is equal to 5. And now I continue. This is a positive 1, so I take it away. I also do the same on this side. So 2x is equal to 4. I will write this step. Then I divide both sides by 2 to get my x as a 2. And therefore I conclude that therefore x is equal to a 2 and y is equal to 1. So let us try again using substitution method, and we'll see whether we get the same solutions. So under substitution, I will use one of the equations, preferably this one, which is having one term with a coefficient of 1. The y is having a coefficient of 1. It is okay to use this one also, but if there is an equation in this form, it is better to use that. So in such an equation, I'm trying to make one variable a subject. The subject of the formula or of the equation. That means I will take this 2x to the right by subtracting it from the left. So I also subtract it from the right. So I end up with y equal to 5 minus 2x. And I can call this one equation star. Now when I come back to my second equation, which is 4y plus 3x equal to 10. This is what I will do. 4y plus 3. Where am I having get x? Oh, sorry. It is a y. We made the subject. So where I'm having a y, I will substitute there 5 minus 2x. And the remaining other things will just remain as they are. So 4 will make this a 20. 4 will still make this one negative 8x plus 3x equal to 10. Equal to 10. So I end up with a 20 negative 8x plus this one. I get a negative 5x equal to a 10. So I need to remove this 20 on the left. So 20 minus 20 minus 5x is equal to 10. Still minus 20. So I end up with negative 5x equal to a negative 10. 10 minus 20 is a negative 10. Rewrite this step, then divide by negative 5 by negative 5. And this will give us our x as a 2. And after getting our x, we shall now go to equation start. And we say that our y is 5 minus 2x. And now our y is 5 minus 2. Where am I having x? I will put there a 2. So my y will be 5 minus 4, making my y 1. That will also conclude that our x is a 2 and y is a 1. Y is a 1. Under the matrix method now, we shall first make sure that if my first equation is 2x plus y equal to 5, I should make sure that also the second equation, which is the x term, written first. So this is now 3x plus 4y equal to 10. And from this, I will extract a matrix, which I will call A. And it will be of the coefficients of these variables, all of these unknowns. So it will have a 2 here, the coefficient here it is a 1, a 3, and a 4. So this is our matrix A. And after getting our matrix A, we shall write an equation. And this equation is starting with this matrix A. This matrix A, and now followed by a column matrix in the order. This is x, y, the order of these unknowns, x, y, column matrix, which we can call a 2 by 1 matrix, and this is equal to another column matrix of these ones, the numbers 5 and 10. We shall always have these unknowns. At least it will be a 0, but it will be there. So after getting this equation, now we look for the determinant. Our aim is to get the inverse of A. But to get this inverse of A, we should be having determinant and adjoint. So determinant of A, which is equal to the difference between the product of the major diagonal. This is the major diagonal. 2 times a 4 minus 1 times a 3. So when we simplify, this is a 8, this will be a 5 at the same time. And after that, we get the adjoint of A, which is also matrix. But now, this one is interchanged. Elements in the major diagonal interchanged. And these elements in the minor diagonal, they are multiplied by negative 1. So we end up with the such. So this is our adjoint. And so we shall get our A inverse by the formula. Inverse is 1 over determinant of A times the adjoint of A. So now our A inverse will be equal to 1 over the determinant, which we got as a 5 multiplying our adjoint, okay, which is 4, negative 1, negative 3, and negative 2. And so this 1 over 5, it is looked at as a scalar which should multiply every entry in this matrix, or every element. So the 1 over 5 should multiply the 4 to give us a 4 over 5. Still, it should multiply this one to give us negative 3 over 5. Still, multiplying this one to give us this. Finally, negative 2. Our adjoint, this is a positive of this. So this is a 2 all over 5. It is a 2 over 5. So after getting our inverse, we are now going to multiply this A inverse on the left hand side and the right hand side of this equation. And in these positions, and in this one. So after that, we shall be having 4 over 5, negative 3 over 5, negative 1 over 5. This inverse, multiplying this equation. This is xy equal to, again in the same matrix, 4 over 5, negative 3 over 5, 1 over 5, 2 over 5. Multiplying itself with the 5 over 10. Sorry, 5 over 10. This is not a fraction. So, given that this is the inverse of this, or is this the product of a matrix with its inverse, when you come to realize where you go to this from, this was what we call matrix A, and this is its inverse. Or is this should give us an identity matrix. So we should get a matrix in this form, which we normally call an identity matrix. And with our xy, our column matrix, equal to, now we multiply here. This with this will give us 20 all over 5. This one will give us minus negative 10 over 5. Again, this one will give us negative 15 over 5. The same row. This will give us 20 over 5. So when we simplify very well, this matrix on multiplication still row by column. This will give us x plus 0. The 1 multiplies the x and the 0 multiplies the y. And now a 0 plus a y. And this becomes equal to, when we simplify this one very well, we end up with a 2. And this ends up as a 1. Negative 15 plus 20 is a 5 over 5, that's a 1. So finally we end with this column matrix equal to this column matrix. And thus we can conclude that our x is a 2 and our y is a 1. Thank you for watching.